What's up, guys? Today we're going to be solving rational equations. So to do this, we're going to use sort of the skills we've been looking at with adding and subtracting rational expressions and a little bit of multiplying rational expressions. But now we're looking at equations, meaning we have an equal sign, and we got to figure out what x is that's going to solve this equation. Okay, so the first thing we want to do is, like when we were adding and subtracting, we've got to get a common denominator everywhere. Well, I noticed that this looks factorable, so I'm actually going to say, is there something I can factor out here? And it's actually an x. So I'm going to just cross this out instead of rewriting the whole thing, and that's going to be x times x minus 2. Okay. Well, if you notice, this denominator is the product of the other two denominators. So this will be the common denominator. I just need to make these two denominators look like that. So I need to multiply this fraction by x minus 2 on the top and bottom, and I need to multiply this one by x on the top and bottom. So that's going to look something like this. So I'm going to multiply it by, let's rewrite this first, 10 over x times x minus 2 plus, I'm going to multiply here by x minus 2, top and bottom. So that's going to be 4x minus 8 over x times x minus 2. Remember to leave your fractions, leave your denominators factored. You leave your denominators factored. Multiply by x top and bottom here. Okay, now that we have a common denominator, since we're adding here, we can freely add and subtract or combine like terms as we need to in the numerators because we have a common denominator at this point. So what I want to do is get everything on one side of the equation. Like usual, when we're solving an equation, it helps to just get x by itself on one side. So I just want to get everything on one side of the equation and get 0 on the other side. So I guess I'm just going to pick this side. It doesn't matter. You can actually move to the left or right. I'm just going to move the negative 5x over, which means I'm going to subtract it from the 4x. I'm going to subtract 5x from both sides of the equation. So I'm going to combine these as well. So 4x minus 5x is going to be negative x. And then the 10 and negative 8 are going to combine to make 2. Over, we have one common denominator, x times x minus 2. And on the other side, what's left, since I moved this whole fraction over, that was really 5x over x times x minus 2. Of course, I moved the whole fraction over. This whole thing is gone, so there's a 0 here now. Okay, so the question now is, how would I solve this equation? Well, remember that the only way a fraction is going to equal 0 is if the numerator is 0, right? 0 over any number is 0. If I say like 0 over 3 or 0 over 5 or whatever, that's all 0, right? So the only way this will be equal to 0 is if the numerator is 0. So at least for now, you can kind of disregard the denominator. We'll come back to that in a minute. But what's going to make that numerator 0? Either set that equal to 0 if you need to, or maybe you can just realize by looking at it, but that has to be a 2, right? X has to be 2. Let's solve it this way. Let's say negative x plus 2 equals 0. Just set that part equal to 0. Draw a little line there. I can subtract 2 from both sides and then multiply both sides by negative 1. X has to equal 2. Well, in the world of any other type of equation, really, you'd be done. That's the answer, x equals 2. You can clearly see that if I plug a 2 in here, let me get negative 2 plus 2, and that gives me a 0, and 0 over anything equals 0. Well, as it turns out, this is not really a valid solution. And this is something that's fairly unique to rational functions, and that is the idea of an extraneous solution. An extraneous solution is one that, while it seems to solve the numerator, when you actually plug it in for x, you get some type of error, some type of undefined situation. So if you were to plug this 2 in for x, yes, you would get 0 in the numerator, but look down here, you get 2 times 2 minus 2, and 2 minus 2 is 0. And remember, you can't have, this would make the whole denominator 0, and you can't have a 0 in the denominator of a fraction. So what we really do is, once we've got a solution, or something that you think is a solution, go back to the very original part of the problem. If I were to plug in a 2, would I get a 0 in a denominator anywhere? And you can see right here you would, most clearly. If I plug a 2 here, 2 minus 2 is 0, and you can't divide by 0, so it's going to be undefined here, okay? That means this is not really a solution, which means, as it turns out, in this problem, there is actually no solution. That would be the correct answer to this problem. In rational equations, you always have to check your solution. Go back to the original denominators and say, if I were to plug this solution in everywhere, would it give me a 0 in a denominator? If it would, then that's not really a solution. So this actually has no solution. Okay, so we're going to do another example. Now, as you look at this, this looks like it's factorable. So you have to ask the question, is this factorable? Are there two numbers that multiply to make 8 that add up to make -6? And as it turns out, it's -2 and -4. So if you were to multiply these two denominators, you would get this. -2 times -4 gives you +8, and they add up to make -6. That means I can actually rewrite this using the other two denominators, x minus 2 times x minus 4. So once again, you have a denominator on the right, which is the product of the two on the left. Okay, so our common denominator is x minus 2 times x minus 4. So all I've got to do is multiply this by x minus 4 top and bottom, multiply this by x minus 2 top and bottom. So over here, when I multiply by x minus 4, I'm going to get x squared minus 4x over x minus 2 times x minus 4. And on the right over here, I'm going to multiply by x minus 2 and get x minus 2 times x minus 4 on the bottom. And I'm just going to rewrite what's on the other side. It doesn't matter what order you write these denominator factors in. I would try to keep them the same for each one, but it doesn't really matter mathematically. Now we have common denominator everywhere. We can actually just combine like terms on the top. So I want to get everything on one side. So I'm just going to combine this all into one fraction. I'm going to subtract this from the other side as a -2. Okay, so I'm going to get x squared. There's no other squared term. I've got a -4 plus an x, so that's going to be minus 3x. I've got a -2 and I'm subtracting another 2, so I'm going to have -4 over x minus 2, x minus 4. And I've got equals 0 on the other side. Remember to put that 0. Okay, can we factor the top? Are there two numbers that multiply to make -4 that add up to make -3? It would be -4 and 1. So I'm going to say x minus 4, x plus 1, x minus 2, and x minus 4. So remember, now our question is, we've got everything in one fraction. So the question is, what would make the numerator 0? It would be 4 and -1. Remember that when something is factored, that's all you've got to look at. What would make these two factors 0? A +4 or a -1? So it would seem that the solutions are x equals 4 and -1. But we have to check for extraneous solutions. If I were to plug in a 4 or a -1 back in the original problem, the -1 would be okay. I could plug in a -1 into any of these denominators and be okay. But if I plug in a 4, I'm going to get a 0 right here. And it only takes 1. If you see a 0 anywhere in the denominator, then that is an extraneous solution. So the only real solution is x equals -1.